Hi, my name is John, and I will be going over Algebra 2 Common Core by Pearson, Chapter 4, Section 1. It's called Quadratic Functions. Just sit back, relax, listen to the show. If you want to take notes, pause it, take a look at the notes, or take notes. I think it's the best way to learn. Okay? So, Chapter 4. We're going to look at what's called quadratic functions, and let's start with I like to start with examples first, okay? So let's look at some quadratic functions are something like y is equal to ax squared plus bx plus c. That's called the standard form. And we're not going to look at standard form very much. We're going to start look at components of standard forms a little bit later on, okay? Just remember that f of x equals ax squared plus bx plus c is called the standard form. Let's just start off with some basic one. Y is equal to x squared. Notice that the highest power, which we call the degree, is 2. Where does the degree come from? It comes from this power right there. The highest power is, I call God, little God, because it's the highest power. If the degree is 3, then it's x cubed. Got it? So the degree is 2, and that's the highest power. So let's start with this equation first, and let's take a look at what it looks like, all right? And I'm just going to draw it for you first. At x equals 0, square it, my y value is 0, right? 0 squared is 0. So it's going to be 0, 0 right there. At x equals 1 squared, you get 1. So x equals 1, my y value is 1. X equals 2 squared. At 2 squared, I get 2 squared is 4. 1, 2, 3, 4. X equals 3 is going to be 9 way up here somewhere. Got it? How about negative 1? What is f of negative 1? That's equal to negative 1 squared, right? We plug in the number. You have to put parentheses around it because there's a minus. You square it, becomes, what's negative 1 squared? It's equal to negative 1 times negative 1 is positive 1. There it is right there. Wow. At negative 2, it's going to go up 4 units. So that's what a parabola looks like. And we have actually names for this right here. So let's start doing some vocabulary, okay? Of course, by now you should know what that point is called. It's called the vertex. And it's centered around 0, 0, which is called the origin, right? And since it's going up and down, it's going to be a minimum. It's a minimum because it's the smallest point. It's the lowest point. That's why it's called a minimum. Okay, what else? We also have what's called the AOS, axis of symmetry. Does anybody know what axis symmetry is? It's located right over here. When you fold a butterfly, here's a butterfly, and you fold it in half like this, right? It turns into an axis symmetry located right over here. You see at the left is equal to my right. And so this is called the AOS, axis of symmetry. And you have to also give me the equation for that axis symmetry. Since I use pink, I'm going to use pink here. The axis symmetry is x is equal to 0. X is equal to 0 is here. If this is the axis of symmetry, it's x equals 2. Got it? In fact, where does a axis symmetry come from? Let's take a look at, I'm going to use lime green. This 0 comes from this 0 of your x-coordinate of your vertex. So this right here and this right here, same point. Okay? So basically it's a pretty simple graph, all right? Let's go on to page 2. Let's try a different one now. Let's look at y is equal to negative x squared. What does that look like? Well, at x equals 1, you square it first. 1 squared is 1, and you take the negative of that, it's negative 1. So 1, negative 1 is in quadrant 4. By the way, when you plug in 0 squared, you get 0. Negative of that is still 0, and so y value is 0. How about if you plug in negative 1? Negative 1 squared is positive 1, and the negative of that is negative 1. Oh, it also looks like a parabola. What do you notice the difference between this and the previous example? You notice that this negative now is a reflection about the x-axis. Okay? We call this value the a value, by the way. So let's say a right over here. This is your a value. So if a is greater than 0, what's another word for greater than 0? Does anybody know? Pause your YouTube video a little bit. See if you figure out what a is greater than 0 means. It starts with the letter P, by the way. Give you a couple of seconds. Okay. If you don't know what a greater than 0 means, a is positive. Whoops. Obviously, if a is less than 0, it's going to be a is negative. Right? Notice that a is negative, so we got a little frowny face. An easy way to remember it is very simple. Y equals x squared. A is greater than 0. In fact, a equals 1, right? There's a positive 1 right there. That means that it's a smiley face. We like positive things. Let's try a y equals negative x squared. A is less than 0. It's negative, right? In fact, a is negative 1 in our case. It's going to look like a frowny face. See that? You don't like negative things. So it goes upside down. If a is negative, positive, x is the coefficient is positive. Okay? So that's how that works. Let's try something a little bit different now. I'm going to still use the space right here. Let's go right over here a little bit. What if now we have y equals 2x squared? What does that look like graphically? Well, you can use your TI-84 plus calculator or thereabouts. At x equals 1, square first. PEMDAS, by convention, tells you to square that first. Use the exponent first. 1 squared is 1, and then times it by 2 is 2. So at 1, it goes up 2. At negative 1 squared, it's going to be 1 times 2 is 2, up 2 again. At negative 1, it's up 2. At 0, it's 0. So what do you notice this time about this coefficient where my a value is equal to 2? Well, did it get skinnier or did it get fatter compared to this one? Or compared to the previous example? Let's use another blue one right over here. Y is equal to x squared. At 1, it was 1, right? So this one, y equals x squared, is fatter. When the coefficient is greater than 1, it gets skinnier. Got it? That's what we can learn from there. In fact, we call this a vertical stretch by a factor of 2. Let's do this again. Vertical stretch by a factor of 2. Okay? So if this is like 10, it becomes extremely skinny. All right? Let's go on to some more examples. Let's go to the next example. Let's go to y equals 1/4 x squared. What does that look like? At x equals 0, y value is 0. At x equals 1, squared is 1. Times it by 1/4 is 1/4. At 1, it's going to be 1/4 instead of 1. Oh, it got lots fatter, didn't it? So we say that this was a horizontal stretch of a factor of 4. Where did this 4 come from? It comes from right over here. So it's the reciprocal of 1/4. What is the reciprocal of 1/4? It's 4, right? So if this is 3/4, then this would be 4/3. Horizontal stretch by a factor of 4/3. Okay, let's try a different problem now. We're getting to almost the 15-minute mark. I want to go maximum 15 minutes on this if I can. Let's get y equals x squared plus 2. What does that look like? Well, I'm just going to graph it for you up to, and that's what it looks like. Let's look at the domain. The domain is if you squish this and put everything on the x-axis. So for instance, this point would go here, this point would go here, this point would go here, this point would go here. It seems like the domain is all real numbers, right? And the interval notation for that is -8 to infinity, comma, positive infinity with the parentheses. Okay, whenever you put infinities, you have to put parentheses. Well, what is the range? Let's use blue. The range is right here where it gets squished in the y direction. This point became here. It's like everything gets squished along the y-axis. So therefore, the range is inclusive of 2 to infinity. And that is the range. Okay? This is interval notation. You can say f of x is greater than or equal to 2 because it includes 2. This means inclusive of 2. Okay? Well, let's try a different problem now. Let's put y is equal to x minus 1 squared. What would that look like? We said that this was a vertical shift of 2 units up, correct? What do you think this one was then? Do you notice that this is on the outside, this is on the inside. So, outside, inside. Minus 1. Do you think it got switched, shifted 1 unit to the left or to the right? Well, if you look at it and you graph it out, it actually got shifted 1 unit to the right. And that's what it looks like. Y equals 1. So where's the vertex of that? The vertex of that is going to be 1, 0. Okay? And there it is. Is it right side up? We know it is because my a value is 1. A value equals 1. A is greater than 0, in other words. Right? Well, let's put it together now. Okay? And this is where the fun begins. Let's put f of x is equal to -2 parentheses x plus 7 squared minus 5. Well, tell me everything about this graph. -2 x plus 7 squared minus 5. So there's a vertical shift of down 5 units. That's a -5 right there. This one is to the left 7 units. Left 7 units. So what is your vertex? From here you can find your vertex. Can you figure out what the vertex is? Give you about 2 seconds or pause it. Your vertex is going to be -7, comma, -5. And so we kind of like want to draw a particulars of that vertex, -7 and -5. It's going to look something like this. So that takes care of this one and this one. What about this negative? What does that tell you? Oh, it just means it's upside down. This means stretch by a factor of 2. Is it skinny or fat? This is skinny, in other words. So it's skinny, and it stretches by a factor of 2. We know it's negative. That means it's going to be a. Is this? Remember previously when we did this, y equals x squared? We said that this was a minimum value, right? What do you think this point is called then? That vertex point. That vertex point has a very special name as well. It's called a maximum. Instead of a minimum, we have a maximum at this vertex. So the vertex is 7, negative 5. What is the equation of your axis of symmetry? Your axis of symmetry is going to be, x is equal to negative 7. That's your AOS. And we also need to find the domain. The domain for all parabolas are all real numbers for the domain, which is negative infinity to infinity in interval notation. Your range is going to be anything below negative 5 on your y value along the y-axis. So it's going to be bracket negative 5 to, I have to start at negative infinity with the parentheses to negative 5. So you always start at the lowest point to negative 5 inclusive. Does that make sense? Go over interval notations a little bit. What else? I need to find the axis symmetry, vertex. It's a minimum. We found the domain and the range. And the last thing we're going to do is, so what is the general form? Or they call it the vertex form. It is f of x is equal to a times x minus h squared plus k, where your vertex is at h comma k, and a is greater than 0, it's going to be a smiley face. A is less than 0, it's going to be a frown. And that's it. That is your vertex form. So we created the vertex form of the parabola. Well, let's do one last example to figure out. I'm going to do example 5 from the book. Example 5 from the book looks something like this. Example 5. They say that the vertex is 3, 7. That's your vertex. And the way you do that dolphin parabola is you have to eyeball it. At the highest point, it's going to be like at 3, it's going to be up 7. It's going to look something like this. Okay? So there's your vertex. And they also give you a point. And the point that they chose was, let me see, what point did they choose from the graph? They chose 9, 4. And the way you have to eyeball it, at the x value of 9, the y value happens to be approximately 4. Well, let's do a gut check on this. Gut. What does your gut say regarding the value of a? Is it greater than 0 or less than 0 according to page 198? According to this dolphin, where it's jumping up through this water. Well, as it jumps up, it looks like it's going to be a frowny face. That means a has to be less than 0. That's our gut. That's what it says, right? So let's take a look. Y equals a times x minus h squared plus k. Always write your formula down so that you know what points you're given. This is your h, this is your k. Substitute it in. Y is equal to a parentheses x minus 3 squared plus my k value is 7. So I put that 3, 7 so that I know which one goes first. H comes before k. There's my h, there's my k. How do I find this a value now? This is where it gets a little bit tricky. Well, to find this value, I plug in this point. So let's plug it in. That's your y value, that's your x value. So we plug in 4 for your x equals a times 9 minus 3 squared plus 7. 9 minus 3 is 6. Squared is 36. So a times 36. 36 times a plus 7 is equal to 4. To solve this out, you subtract 7. Get rid of that. So you end up with negative 3 is equal to 36a. I'm going to divide by 36 to both sides. That gets rid of that. I reduce it. My a value is equal to negative 1/12. Right? Reducing that. Oh, what did our gut say? Our gut said that a is less than 0 because we know that it's going to be a frowny face, right? So my equation is now going to be y is equal to a, which is negative 1/12 times x minus 3 squared plus 7. This should help with most of your problems on chapter 4, section 1. Sorry I went over 5 minutes on this. Good luck, guys.